In this video, I'm going to go over permutations, factorials, and the fundamental counting principle. The fundamental counting principle states that if we have A ways to do one thing and B ways to do another thing, then we have A times B ways to do both things. Let's look at an example. James has 5 pairs of pants, 10 shirts, and 2 hats. How many different outfits can James make using one of each of these items? So the key here is one of each of these items, okay? So he needs to wear one of 5 pairs of pants, one of 10 shirts, and one of 2 hats. So we can write this using the fundamental counting principle as 5 times 10 times 2. And that's going to be 100 possibilities. So James can make 100 different outfits using one of each of these items. Let's try this question. How many 4-digit even numbers are there? So let's draw out our 4 digits here, or our 4 spots for digits. And then the key here is even. So we know that in order for a number to be even, the last digit has to be 0, 2, 4, 6, or 8. So that's 5 possibilities for the last digit. Now the first digit can be any number 1 through 9. It cannot be 0, because if it were 0, then the number would actually only be 3 digits. So 1 through 9, that's 9 possibilities. Now our second and third digits can be 0 through 9, so that's 10 possibilities. So 10 possibilities for the second digit and 10 possibilities for the third digit. Now we can multiply all of these together to get the amount of 4-digit even numbers. That's going to be 4,500. Let's try another example. How many 4-digit even numbers are there without repetition? And now, what without repetition means is, it means we cannot use one digit more than once. So all 4 digits have to be different. So as we said previously, in order for this to be an even number, the last digit has to be 0, 2, 4, 6, or 8. So that looks like 5 possibilities for the last digit. Now, because there's no repetition, the first digit cannot be the same as the last digit. Previously, we said that there were 9 possibilities for the first digit when we were allowed repetition. Because it can't be the same as the last digit, there should be only 8 possible digits. But actually, we have to consider 0. Previously, when we were allowed repetition, the first digit couldn't be 0 because that would make it 3 digits. So actually, if the last digit is 0, there still are 9 possibilities for the first digit. So we have to split this into 2 cases. So for our first case, the last digit can be 2, 4, 6, or 8. For our second case, the last digit can only be 0. So I'll just write this out, case 1 and case 2. In our second case, there's only one possibility for the last digit, and that's 0. For our first case, there are 4 possibilities, 2, 4, 6, or 8. So let's look at our first case. The first digit, there are 8 possibilities. 1 through 9 minus whatever is used for the last digit. For our second digit, there are also 8 possibilities. 1 through 10 minus whatever is used for our first digit and minus whatever is used for our last digit. So 8 possibilities. For our third digit, there are 7 possibilities because we can't use the first, second, or final digit again. So 10 minus 3. Now looking at our second case, There are actually 9 possibilities for the first digit because it could be 1 through 9. None of those have been used yet since the last digit was 0. Our second digit, there are 8 possibilities, and our third digit, there are 7 possibilities, just like case 1. Now let's multiply all of these together for case 1, and we get 1,792. Now when we find all of the possibilities for case 2, we get 504. Now let's add the two cases together, and we will find that there are 2,296 possibilities. So there are 2,296 4-digit even numbers without repetition. In this next situation, James has 4 homework assignments to do in the afternoon. In how many possible orders can he do his homework assignments? So he has 4 assignments and he has to do all 4 of them. First, he can choose from 4 different homework assignments. After he chooses one, he can choose from the 3 remaining ones. After that, there are 2 remaining ones to choose from. And then there's the one assignment that he left for the end. So we can multiply these together, and we'll find that he has 24 possible orders that he can do his homework assignments. We can also represent this 4 times 3 times 2 times 1 with 4 and then an exclamation point, which is also known as 4 factorial. So when we talk about factorial, we're talking about a number and then with an exclamation point. And what that really means is the number times the number minus 1 times the number minus 2, and it continues all the way until it's multiplied by 2 and then multiplied by 1. So let's try an example. 5 factorial is equal to 5 times 5 minus 1, which is 4, times 5 minus 2, which is 3, times 2, times 1. So that's going to be 120. Now here's some common factorials. So 1 factorial is just 1. 2 factorial is 2 times 1, which is 2. 3 factorial is 3 times 2 times 1, which is 6. And 4 factorial is 4 times 3 times 2 times 1. So there's a real pattern here. Let's try another example. James's math class has 8 students and 8 desks. How many different ways can the students arrange themselves in these desks? So let's draw out the 8 possibilities, the 8 desks. We'll represent them with these little lines here. And then the first desk, there are 8 possibilities. There are 8 different students that can sit in that desk. There are 7 possibilities for the next desk because one student already sat down in the first one and there are 7 students left. Next, there are 6 students, and then 5 students, 4 students who aren't seated, and then 3, 2, and 1. So this is the same as 8 factorial. So to solve this problem, we could have just used 8 factorial. Let's try this problem. How many ways can the letters in the word Mississippi be arranged? Well, there are 11 letters, so it's intuitive to think 11 factorial. But what you have to notice is that there's repetition in the letters. Some of these letters are used more than once. For example, I is used 4 times. S is also used 4 times. And then finally, p is used twice. In order to account for this, we have to divide our 11 factorial by the factorial of each repeated letter. So because there are 4 i's, we have to divide 11 factorial by 4 factorial. And because there are 4 s's, we have to divide it again by 4 factorial. And because there are 2 p's, we have to divide it again by 2 factorial. Here's another example. James has 10 shirts and he wants to wear a different shirt every day this week. How many possible ways can he do this? Well, there's 7 days in a week, so let's draw out 7 possibilities here. Let's draw out 7 columns. On the first day, he has 10 shirts to choose from. On the second day, he has 9 shirts to choose from because he already picked one on the first day, and there's no repetition. On the third day, he has 8 shirts to choose from because he can't choose the same one he chose on the first or second day, and then this pattern continues, 7, 6, 5, and on the last day, he has 4 shirts to choose from. Now we can multiply all of these possibilities together to find how many possible ways he can do this. However, there's an easier way to represent this. This is actually the same as writing 10 factorial divided by 3 factorial. Now I'll show this. So 10 factorial, that's 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which is the same as 3 factorial. 3 times 2 times 1 is 3 factorial. So we can divide this by 3 factorial, and the 3 factorials cancel out. So then we're left with our answer, 10 times 9 times 8 times 7 times 6 times 5 times 4. This is actually an example of a permutation. So a permutation is really an arrangement of numbers. We often use the notation N, P, R to demonstrate a permutation. So permutation really is n factorial, and n represents the number of items in the permutation, and we divide that by n minus r and take the factorial of that. And what r represents is the amount of items, or the number of items that we take in the permutation. So n is the possibilities, and r is the amount of these possibilities that we actually use. So let's look at that same example with the shirts, and let's use our new knowledge. So in this case, n, the amount of items is 10. There are 10 shirts that James can choose from. Now in this case, r, the amount of items that we're taking, is 7, because there's 7 days in 1 week. We can write the solution to this problem as 10p7, which is equal to 10 factorial divided by 10 minus 7, and we take the factorial of that. So that's really the same as 10 factorial over 3 factorial. So this is actually the same as 10 times 9 times 8 times 7 times 6 times 5 times 4, which is exactly the same answer we got when we did this question previously.